In this video, we're looking at the mole and the Avogadro constant, and also determining the number of particles from molecules and compounds. Without further ado, let's start. So what's the mole? The mole is a convenient unit used to count very small particles, such as atoms, molecules, or ions. It is similar to other counting units that we use in our everyday lives, such as you say dozens of egg, that's 12. Whenever you hear dozen, it's 12 pair of shoes. The mole is the SI unit for amount of substance. The amount of substance is a measure of the number of specified elementary entities in a sample, and elementary entities can refer to atoms, molecules, ions, electrons, or any other particle that we know of in chemistry. So recently a new definition of the mole was announced, to be precise in 2018, according to the IUPAC, the International Union of Pure and Applied Chemistry. So it goes by: a mole is defined as containing exactly 6.0221407 times 10 to the power 23. So in the past, we used to define mole as the amount of substance that contains the same number of particles as their atoms in exactly 12 grams of isotopes of carbon 12, and a lot of textbooks still use this, so it's still crucial to know this definition. So secondly, we have the Avogadro constant. What's the Avogadro constant? Symbolized by L or Na, is the proportionality factor that relates the amount of substance with the number of particles. And you should know the difference between Avogadro number and Avogadro constant. Avogadro number has the same numerical value as the Avogadro constant, but it does not have any unit or is dimensionless. And you don't have to memorize the Avogadro constant in your head, as it's given to you in the data booklet. For most curriculums, especially in the IB diploma, you get the Avogadro constant in the data booklet, so there's no need to memorize it. And also, this is the number for the Avogadro constant, which is 6.02 times 10 to the power 23, and it's given to us in three significant figures. So the number of particles or elementary entities in a mole of a substance is numerically equal to the Avogadro constant, which has a value of 6.02 times 10 to the power 23. So what this means is, in any particle, whether it is atom or molecule or ion or formula unit or electron, the number of particles in one mole is the same, which is 6.02 times 10 to the power 23. But that doesn't mean the mass is the same. They might have the same number of particles, but different substances have different masses. That's one thing to remember. So this table right here makes what I said valid. So take note of that. And the mass of one mole of a substance is its molar mass, and I will talk about molar mass in my next video. So we have example. Our first example is: determine the number of hydrogen and oxygen atoms in one mole of H2O. So in order to do this, first we need to know how many hydrogen elements are in the water and how many oxygen elements are in the water. So for hydrogen, we have 2 hydrogen elements, and for oxygen we have just 1. So to find the number of hydrogen and oxygen atoms, what we need to do is simply multiply the number of hydrogen by the Avogadro constant. And also the number of oxygen by the Avogadro constant. So the first one gives us 1.20 times 10 to the power of 24. and the second one is the same as the Avogadro constant. So let me conclude by saying that we have this number of hydrogen atoms in water and this number of oxygen atoms in water. So our second example, determine the total number of atoms in 2 moles of benzene. Remember the difference between the first and the second question is the second question says 2 moles. So there are 2 moles of benzene. So they didn't specify it by saying find the number of carbon in the hydrogen, they say the number of atoms. So since they say the number of atoms, we simply add 6 plus 6, that's 12. 6 carbon and 6 hydrogen. So to find the number of atoms, what we are going to do is multiply 12 times 6.02 times 10 to the power 23. And it's the same as the first one, but what's different here is you have to multiply by 2 since I said 2 moles of benzene in order to get your answer. So this will leave you with 1.45 times 10 to the power 25 atoms. I hope you liked my video. Please subscribe to my channel for more videos like this.